I've decided to just do the VLAN presentation from the same person that did those other talks. It seems to give a good illustration of the difference between VLANs and subnets, and so it's about 10 minutes, and then I'll spend the rest of the time question and answers, as well as just give you sort of my take on how you can use VLANs in your everyday environment. So here goes.
Hey YouTube, in this video we'll answer the question, what are VLANs?
Good. Very good.
This is a network topology with 3 switches and 2 routers. The routers create network boundaries, which means we have 3 total IP networks on this topology. The routers facilitate the communication between these networks, and the switches facilitate all the communication within these networks. If you understand all this, then you can understand the first major function of a VLAN. VLANs allow you to break up one physical switch into smaller, virtual mini switches. This topology above, with 3 physical switches, could be recreated with 1 physical switch and multiple VLANs. Each VLAN acts as its own independent mini switch. And just like in the topology above, each VLAN handles all the communication within each network. And the routers, just like before, continue to facilitate the communication between each network. These 2 topologies operate exactly the same. A VLAN is simply a number assigned to each switch port. On this switch, someone configured this port and this port to be a part of VLAN 10, and these 2 ports to be a part of VLAN 20, and these 2 ports to be in VLAN 30. Once that happened, these ports now act as an independent switch detached from the rest of the switch ports. The switch will always ensure if a frame comes in on a particular VLAN, it can only go out the other ports in the same VLAN. Even if host A sent a frame with a destination MAC address of host B, the switch would not forward it out the port in VLAN 30. You can consider it as if each VLAN maintained its own independent MAC address table. So, the first major function of a VLAN is that VLANs allow you to break up one physical switch into smaller virtual mini switches. The second major functions of VLANs is VLANs allow you to take those virtual mini switches and extend them to other physical switches. Notice here we've extended VLAN 10 and VLAN 30 to another physical switch. Each switch's VLAN configuration is independent, which means on this top switch someone had to configure these 3 ports in VLAN 10. And on this bottom switch someone had to configure these 2 ports in VLAN 10. This links the VLAN 10 ports in the top switch to the VLAN 10 ports on the bottom switch. This topology functions exactly like this topology. In fact, you could even consider this the logical topology and this the physical topology. Either way, a packet from host C to host T goes through the red switch, or VLAN 10, then through this router, then through the orange switch, or VLAN 20, then through this other router, then finally through the blue switch, or VLAN 30, before it arrives at host D. So in summary, the 2 major functions of VLANs are: VLANs allow you to break up one physical switch into smaller virtual mini switches, and VLANs allow you to take those virtual mini switches and extend them across to other physical switches. We need to point something out about this method of extending VLANs across multiple physical switches. Notice here we extended 2 VLANs, VLAN 10 and VLAN 30. That requires 2 connections between these switches, one for VLAN 10 and one for VLAN 30. If we had instead needed to extend 15 different VLANs between the switches, we would need 15 connections between each switch. This creates a scale problem, because if these were 24 port switches, there would only be 9 ports left over for actual hosts and routers. Instead, a mechanism was developed which allows multiple VLANs to traverse a single link. Notice here, we only need 1 link between each switch, and that 1 link is carrying both VLAN 10 and VLAN 30. We can actually do the same for these routers. Notice each router has 2 connections to the same switch. These can both be replaced with a single link carrying multiple VLANs. Here, we've made it so that each device only has 1 physical connection to each other device, and some of the links carry only one VLAN and others carry multiple VLANs. Now, links which carry multiple VLANs are known as trunk ports or tagged ports. Links which carry only one VLAN are known as access ports or untagged ports. Now, there is something else to consider. Traffic on the wire is simply a bunch of ones and zeros. If a bunch of ones and zeros arrive on this link from host C, the switch knows they all belong to VLAN 10 because access ports only carry traffic for one VLAN. But here, on these trunk ports, it isn't as simple. If a bunch of ones and zeros arrived, something has to exist to designate which ones and zeros belong to VLAN 10 and which belong to VLAN 30. That something is what we know as a VLAN tag. Each packet has its data payload, then a layer 3 header, then a layer 2 header. Inside the layer 2 header is where the source and destination MAC address appear, which indicate who is talking to who. When a packet traverses a trunk port, an extra piece of information is added inside the layer 2 header, which indicates what VLAN that traffic belongs to. That is the VLAN tag. The way it works is when this switch sends traffic on a trunk port, it marks all the frames with a VLAN tag so the other switch knows which VLAN that traffic belongs to. This is how it works. Notice, every time a packet is crossing a trunk port, a VLAN tag is added to tell the receiving switch what VLAN that traffic belongs to. This is what the VLAN tag actually looks like on the wire. On the left, this is a packet as it comes in to an access port. Notice the layer 2 header has 3 fields: type, source, and destination. On the right is what the packet looks like as it goes through a trunk. The standard for what goes inside a VLAN tag is 802.1q. This is simply the rules which govern what a VLAN tag actually looks like on the wire. 802.1q VLAN tags add this part right here. There are a few fields in the VLAN tag, but the important one is down here. This field indicates that this packet should be associated to VLAN 10. This is the same illustration as earlier, and is still an accurate logical representation of what you are looking at above. Traffic from host C to D is still going through the exact same path and the exact same process logically. The only thing that is different is the physical topology. In the end, one of the key benefits of VLANs is your logical topology is not constrained by your physical topology. Before VLANs, your physical topology greatly affected your desired logical topology. VLANs eradicated that problem entirely. Now there is one last concept we need to discuss before we wrap up our discussion of VLANs. Let's just focus on this bottom switch and trunk port for a minute. If this trunk port receives a frame tagged for VLAN 10, the switch will only send this frame out VLAN 10 ports. If this trunk port receives a frame tagged for VLAN 30, the switch will only send the frame out VLAN 30 ports. But what happens if a frame arrives without a VLAN tag? The switch has to associate the frame with a VLAN so it knows which ports are eligible to receive this frame. 802.1q provides for a way to set a fallback VLAN, so that if an untagged frame arrives on a trunk port, the switch has a VLAN it can associate the untagged traffic to. That feature is known as the native VLAN, or the PVID, the Port VLAN ID. It is a per trunk port configuration, and any frame that arrives without a VLAN tag is automatically associated with the native VLAN. In this case, this trunk port's native VLAN is 10. Therefore, this untagged frame will only be forwarded out VLAN 10 ports. The native VLAN also plays a role in sending frames as well. For example, if host D sends a frame, it'll arrive on the switch on an access port in VLAN 30. So the switch will associate this frame with VLAN 30. When the switch tries to forward the frame out the trunk port, it'll first check the local native VLAN configuration. If the frame it is trying to send does not match the native VLAN, it'll tag the frame and forward it as normal. If, however, a frame is meant to be sent across the trunk that does match the native VLAN, a tag does not need to be added, and the frame will be sent out untagged. So to quickly review, if a trunk port receives a frame with a tag, the frame will be associated with a tag VLAN. If a trunk port receives a frame without a tag, the frame will be associated with a native VLAN. If a trunk port is sending a frame that does not belong to the native VLAN, the frame will be sent with a VLAN tag. And if a trunk port is sending a frame that does belong to the native VLAN, the frame is sent without a VLAN tag. The native VLAN is simply the one VLAN that's allowed to traverse a trunk without a VLAN tag. So, to summarize everything we've learned, VLANs provide two major functions. One, they break up physical switches into virtual mini-switches. And two, they extend those virtual mini-switches across multiple physical switches. This allows your logical topology to be unconstrained by your physical topology. We learned that access ports, or untagged ports, are ports which carry traffic for only one VLAN. And we learned that trunk ports, or tagged ports, are ports which carry traffic for multiple VLANs. We learned that the standard for tagging traffic is known as the 802.1q standard. And we learned that the native VLAN is the one VLAN which is allowed to traverse a trunk or tagged link without a VLAN tag.
So hopefully that gave you a good overview of what a VLAN is, and perhaps how it differs from subnetting. So I was going to say, one thing I wanted to tell you is that with normal home routers and switches, they don't expose VLANs directly. However, in some cases, that router may be doing VLANs under the cover. For example, I didn't realize this, but I learned this yesterday. All of your routers probably have a WAN port and then 4 or 5 LAN ports on the back, correct? You plug the WAN port into your cable modem or whatever your internet provider is, and you can plug your devices that are inside your network on the LAN ports. And there's segmentation between the LAN port and the WAN port, or the LAN ports and the WAN port, right? So they can't see each other, and you need to do something like NAT to connect the two, right? The router function. One of the ways that routers will actually do that segmentation is it'll put the WAN port on a separate VLAN than the LAN ports. That way they don't see each other. And then you have the router sitting in the middle that's basically allowing traffic to flow and doing the natting and giving you the ability to set firewall rules, etc. So thought that was kind of interesting. So does anyone have any questions about that video? And if not, I can kind of talk about the way that I use VLANs in my environment, and whether or not it makes sense for you.
What?
What?
Talking about your home environment?
My home environment, yeah.
Well, I'll be interested to see what a VLAN could do in a home.
Well, it
Not
can do a
that
lot.
complicated.
It can do a lot of things. I mean, as they said in the video, it segregates things. If you're really concerned about security, you put things on their own VLAN, so they're
So
logically.
Peter, you mind if I answer this one?
Yeah, no, Seth, this is your show. I'm sorry, I'll shut
All
up.
right, cool. So if in your house you have some Internet of Things device, you got a motion sensor, that's controlling a smart light, okay? And you have your laptop that has all of your good, juicy stuff on it, like, you use it to log into your bank account, etc. You rely on the fact that bad guys who are sitting outside on the public internet can't get to your laptop because you have a firewall in that home router, correct? However, if you have that IoT device that is able to talk on the internet, okay, that's sitting on the same network inside the router in your home, there's nothing that will stop an attacker who hacked into your Internet of Things device to have direct access to your laptop, okay, to start hammering away or, to use your, network to basically do denial of service attacks against people, etc. Okay. So what VLANs do is give you the ability to put those IoT devices that you can't really trust because again, you don't know what's going on. You don't know if they have up-to-date firmware. You don't know if it's being sold with malicious code on it, etc. Okay. So if you segment those on a completely separate network, okay, then you're safer. So you can do that one of two ways. You can do that with VLANs, which is basically how you have the traffic where your IoT devices are cannot, it's completely disconnected from the traffic where your laptop is going. Okay. The other way that you can do it was with firewalls and with subnets, but it's kind of hard to do multiple subnets, you know, without, with a normal environment. Okay. So what I do is I have a router that supports multiple subnets, and the subnets are basically tied to separate VLANs. Okay. Does that does that make
Do you have a
sense? I don't
separate
know if
box for
I
the VLAN? Is that self-contained within the router, or is that a separate box?
um it depends. There are routers, okay, that if the router has VLAN support that you can use, then the router will support the VLANs on the switch ports on the back. So you could put, like I said, let's say there's 5 ports on the back of your router. You could put each port on a separate VLAN. You could put 2 of the ports on one VLAN and 2 of them on the other, etc. Most likely, if you're using VLANs, um, you will have an additional switch uh, that you can use. And in order to use VLANs, you need what's called a managed switch, which typically has a nice web interface that allows you to configure all of that stuff that the guy was talking about. Like what is the VLAN associated with each port? Is this port a trunk or is this a regular access port, etc.? And the router knows how to assign VLANs to subnets. Okay. So in my case, I have a router that supports VLANs. I have 3 subnets. I have let's say a dot one, a dot two, and a dot three. Okay. So, and the dot one is on VLAN one, the dot two is on VLAN two, and the dot three is on VLAN three. Okay. I have a DHCP server running on each of those subnets. Okay. So if you plug into a port that's on VLAN 2, you will get an IP address that's 192.168.2. something. If you plug into the port for VLAN 3, you'll get 192.168.10.3, something like that. Okay. My access points, so my Wi-Fi also has the ability to say for this SSID, I can say guest network. That's gonna issue it's going to put you on VLAN 3. So then when you hit the DHCP server on the router, it's going to give you a .3 number. If it's my regular computer network, when I connect to that Wi-Fi, it will give me VLAN 1, for example. Does that make sense? So it all
It
kind of
does.
works together.
Seems like a good idea. Now that they're all, I was kind of surprised when I looked at my router, how many things in my house were accessing it.
So Seth, to answer Jerry's question, which I think is a good question. So why don't you talk through your setup a little more specifically, like which hardware you use? And,
Okay,
and
I will do that. Okay,
I think it'll put some meat on the bones.
yes, perfect. I use equipment from a company called Ubiquiti. Ubiquiti makes prosumer grade equipment. They also have consumer stuff. Um, but it works really nicely. So I have a dedicated router. It's a little box that has 5 ports on the back. It was like $50, okay, but it's very powerful. It is VLAN aware. It allows you to plug in, the cable modem to a WAN port, and it has 4 LAN switches, but it's VLAN aware, so you can assign VLANs to the ports, just like the way he described. Okay. It has a built-in DHCP server and it has built-in DNS, for example, and you can configure firewalls. So that's the little router that I have. And I have wireless access points. Have you ever been in a business and see the little frisbees that are hanging on the ceiling for Wi-Fi? So that's an access point. Okay. So Ubiquity makes these under the brand Unify. Okay. It turns out that those access points are VLAN aware. Okay. So I have three access points sitting on my ceiling throughout my house that are connected to this router. Okay. I also happen to have a managed switch because I ran out of ports. But all that's doing is it's giving me more ports than the four that the router has. Okay. So, and that's how I have it connected. And I happen to have three VLANs in my house. I have one VLAN, which is like my main computer network. I have another VLAN, which is what I call my DMZ, which only has access to the internet. It's similar to a guest network. You plug into it, you cannot talk to the computer network, but you can go to the public internet. Okay. And my third VLAN is a special VLAN that I use that's hooked up to a VPN. So if I want to basically have VPN instead of running a VPN client on my laptop, it's running on the router. So traffic that I send through this one Wi-Fi SSID goes through a VPN. Okay, it's just kind of a convenient way of utilizing a VPN. So any devices that are on that Wi-Fi are basically connected to my VPN.
So Seth, taking what you just said, and maybe I
Yep.
don't understand it correctly. If you're on your computer, you have
Yep.
to change the SSID on your computer to give you the different services?
No. So my computer is on my computer network. Okay. So I connect to the Wi-Fi that's the computer network. The computer
Right.
network can see other devices on the computer network,
Right?
and it can also get to the public internet. And it can also get to the IoT devices. So if I want to manage them. So the firewall rules, okay, say that the computer network is allowed to connect to the IoT network or the DMZ, whatever you want to call it. And it can also connect to other computers on the computer network, and it can go to the public internet. Okay. So that's one. So that's where I put my laptops, my
So your
computer.
your computer network is aware of your VLAN 2 and your VLAN 3.
That's what defines the computer network. So there's a direct mapping between the subnet 192.168.1, okay, and VLAN 1, okay?
Right.
Can I
So,
ask you a question?
yeah,
Okay. So
Can you let him finish what he was saying with my
it's
question?
okay.
Because I think he's in the middle of it.
Steve, go ahead.
okay. Suppose I have 10 devices at home, a couple computers, a TV, and a few other things,
Yeah,
and I want to set up VLANs
yeah.
between them. Does that mean that I have to get a managed gigabyte switch or something of that sort, gigabit switch, and also run wires from each of my devices to this switch in order to set up the VLANs?
Um, Not necessarily. Okay. So, for example, with if you have like whatever you probably have some sort of router, Wi-Fi switch box, right? Like one of these ASUS boxes, whatever that have the antennas on it, right?
Yes, I do.
Okay. So it is likely that out of the box, the software that comes with it does not expose VLANs, but it is very likely that the hardware does. Okay. So one way that you could do this is to install one of the open source software projects on your router box. In this case, there's one called OpenWRT. Um, what they did was they got access to the software that the router companies were using because they were using open source software, which meant they had to publish all of their source code. So these guys took it, made a project, and then they advanced it. They exposed lots of different features. So if you want, you can replace your firmware with that. And once you have that, then you can do all of these things. Okay. And the way it would work on your TV is you would configure a mapping between the TV's Wi-Fi network, which you might want to put on the IoT network, okay, and a VLAN. Let's say, VLAN 2, okay? And VLAN 2 in the router part would be mapped to 192.168.2. Whatever. So when your TV connects through Wi-Fi, it would get an address in the .2 subnet. Okay? And the router would handle all of the magic. You would have firewall rules inside your router that would make sure that if .2 wants to connect, it can only go out to the public internet. It can't go to your laptops. Okay? You would do the same for your laptop network in .1. Okay? You would say, your laptop network would be an SSID, whatever, that corresponds to VLAN 1. It would get a .1 address. You would make firewall rules that allow traffic to go from .1 to .2. Okay? And also from .1 to the public internet. Okay?
So it sounds like if I want to start setting up VLANs in my house, the first thing
Yeah.
I'd want to do is define what virtual networks I'd want to set up and which devices I want to have on them. Then
Yeah.
I have to have a VLAN aware device or devices.
Yes.
Such could be my wireless access point,
Yep.
or it could be a gigabit switch. For instance, one of the ones I'm looking on my Amazon right here, and I would use those. And in any event, I'd have to be connected from each of my devices that I want to assign to a VLAN. There has to be a way of connecting them to a device that can set up the VLANs.
Yes.
So if my computers are wired network, they're not using Wi-Fi because I think it's faster. But
Yes.
if the way it is, then I have to have a wire from each individual computer to the device that supports VLANs.
Well, I mean, it would be the same whether you're using VLANs or not. If you want to use wired, you need a wire from that device to most likely a switch because your built-in router probably doesn't have enough ports, right?
That's right.
It's got to be it's got to be a managed switch, not just a
Exactly.
phone switch.
So
You might
as
have
it turns out,
full VLAN manageability.
I'm going crazy in my network right now. So I just bought, here's an example of a 24-port managed switch that's rack mountable. Okay. So this is the kind of switch that you might put in your, if you had a small business. You can get smaller ones that are cheaper. So you can probably get an 8-port managed switch for $50 or so. Is that what you're seeing, Steve?
I'm seeing $12.
$12 for a managed switch?
Yeah.
That's I would
It's only got one
I would
port.
avoid
It's
that
only got
one.
one port. The input is nothing out.
It's called a cable.
This one right here, for instance.
Yes. That looks like a kind of a no-name brand. I would be more inclined to go with companies like TP-Link, Netgear.
Right there. Here's a 24-port for $100.
That's really good.
16-port
Your
for
challenge,
$59.
avoid Chinese manufacturers.
Yeah, those I would strongly consider. They came down in price quite a bit. The one that I showed you is very similar to that $99 one. The only difference is my switch supports something called PoE. Are you guys familiar with PoE? Power over Ethernet. So yeah, that causes the price of the switches to go up. But because I use those Unify flying saucers on the ceiling, they don't plug into power. What they do is they get the power off the Ethernet cable. So basically, my switch will supply power over a couple of the wires on the Ethernet cable that is also supplying the data connection.
All right, so one thing you didn't talk about, Seth, you sort of glossed over, is your access points are all wired access points.
Yeah, but they don't have to be.
Yeah.
No. And right, so you can get access points that are just you plug it into the wall in the socket, and they're wireless, and they just do
Yes.
their thing.
Yes.
All right. And the other thing that you should at least mention, in my opinion, is that setting this up is not for the faint of heart.
No, I would say that's fair. I mean, setting up firewall rules are not for the. I mean, they're not trivial.
You have to go through a little bit of thought and a little bit and a little bit of design and all this other stuff to do it. I would suggest, without having done it, that your friendly AI companion may be able to give some guidance. I've used it in the past to ask questions like, give me a checklist to do X, Y, and Z. And by and large, I knew what I was doing, and the checklist came back that was reasonable. So I suspect that things like this are well documented. And if you're really not sure, you could ask the same question to multiple AI engines and compare the results, and you'll find that they're very similar, if not identical.
Yes, one thing I would say is I generally use trial and error. You kind of plug it in, and if it works, great. If it doesn't work, try and figure out what setting you need to change. I mean, when I first set this up, I kept plugging things in, everything was great, but no trap. What?
What do you do about the smoke when the switch starts smoking?
You keep a fire extinguisher
So,
handy.
True,
Oh,
so
what you use
true
a firewall
story.
for.
Oh, that's
True
a firewall.
story.
That's right.
It's called a fail-safe.
So true story. Speaking of that, that I'm a little still sore about because it happened about a week or so ago. I have one of these flying saucer, the access points. The thing's probably 8 years old now. Still works great. It's Wi-Fi 5, not Wi-Fi 6, but good enough. Been very reliable. Overnight, a software update was pushed. Okay. In fact, I have 3 of them. 2 of them were working fine. 1 of them wasn't working. It's like, oh man, what's going on? So I started looking at it and it wouldn't power on. Turns out the software update actually burned out the hardware. It didn't brick the device to the extent that, you needed to basically factory reset it or whatever. It actually killed it. And so yes, it is possible you can actually damage permanently a device with software. I've never had that happen before. So I don't think smoke came out of it, but yeah, I don't know what happened and I'm sore about it.
A couple of things. First of all, when you say brick, you mean make it worthless, not working totally.
So
that's what you mean. When you say brick, that's what you're meaning.
Well, typically people use the term, they'll say, I bricked my device. For example, let's suppose you install a bad software build so that when you power it on, the software starts running and then it just hangs or freezes. So you can't do anything. So it's completely dead. That's what people typically mean when they say they brick the device. However, more often than not, you can go to like a lower level menu so that you can push new software to at least get it back and running. Okay. But if something happens that damages the hardware, well, the problem is it doesn't power on anymore, then there's nothing you can do about it. So both in this case are bricked, except this is permanently damaged.
So brick basically means it's useless.
Right. The term is that nice piece of electronics is now as useful as a cement brick, or a mason brick, right?
Now,
That's
I have
all it
another
is.
question. I have another question for you, Seth. You've discussed firewalls on a number of times.
Yeah.
Is everyone here familiar with them? Did you cover that?
I don't think I covered firewalls. I assume most people have used firewalls before. Maybe that's a bad assumption. What a firewall
How many people have used firewalls? I have. Anybody else? Okay.
I have a fire extinguisher. Is that close?
All right.
Firewall.
So let me give a brief overview. What the purpose of the firewall, okay, is to act as a gateway between your stuff and the outside world. Similar to in your car, okay, there's a firewall behind the dashboard so that if the engine catches on fire, that fire doesn't come into the passenger compartment. Or similar in your house, there's like a brick section that prevents fire coming from your chimney, etc., from getting into your home. Okay, so in the computer context, it's software that allows you to define rules for how traffic can flow from one place to another. So your typical firewall would be, don't allow any traffic in from the outside, only allow traffic from the inside to go to the outside. And there's a magical capability that says, if I initiated traffic on the inside to the outside, okay, allow the responses to that to come back. So the firewalls are intelligent and they can understand the concept of what's called a connection. So like if you go to a website, on the outside, it knows what traffic is coming back. I mean, it uses that by looking at the IP address and the ports. So like if the destination and port, IP address and port of your outbound traffic matches the source IP and the source port of the response, then it allows it through.
You have
Now,
to go one step, you have to go one step further there, Seth, is you have to explain the word you used earlier, NAT and AT, because that's involved in the firewall stuff too.
so NAT is something that routers will do typically because you have more IP addresses inside your network than you have public addresses.
And explain
So-
that NAT, just define NAT. NAT stands for Network
Network
Address Translation.
Correct. So what it's doing is it's taking your internal 192 addresses that are not allowed on the public internet. These are only for segmented networks. Okay. So like if you draw a boundary in your home, you can have 192.168 addresses flowing around in your home, but you can't send that through your cable modem to get to Google. That'll get blocked. So what you have to do is convert that 192.168 address to the address, in most cases, that your ISP gives you, which is the one public internet address you get. Okay. I mean, if you want to know what that is, you can go to a website like What's My IP, and it'll tell you your public address. Most people have more than one device inside their network, so you need to do translation from multiple 192.168 addresses to your one public address, and that's what NAT does. One nice side effect of NAT is that there's no way for someone on the outside to get through the NAT in reverse because, they don't know what the address of your computer is. So the NAT basically will block all inbound traffic. So you get the effect of having a firewall.
A little bit more on this, if I might, because I'm have some familiarity with it. If your computer decides it wants to send some information over to, say, Google, okay, what the network address translation will take your internal address, 192.168.1.212 or whatever it is, and convert that to a packet coming from the router with an IP with a port number of like 12345. And it goes to Google. Google responds and sends it to port 12345. Your NAT device says, oh, that goes to Steve's computer, port 212.
That's correct. So there's a table that the router keeps track of to know how to make those translations.
I was a little wrong. My internal address was 212. The port I might have been sending from was 80. And it would know to go from 12345 coming into the router to convert that to port 80 on my machine.
Correct. So that may be why you haven't had experiences with firewalls, because almost everyone is running a router with NAT, and that gives you basically the same protection that a firewall would give you. Because there's no way for something on the outside to get through a NAT backwards unless
It knows
you
support.
started it going forward. Because
Unless
what's
it
going to
knows
happen is
support.
the packet's going to get to your router and there's going to be no mapping. It's not going to know where to send it, so it just drops the packet.
Yeah, one further point there to Steve's point is there are a handful of ports that are used in the world of internet that are common, so that if you're going to send HTML, you go to port 80. If you're going to send HTTPS, you go to 443. And there are other things like that that are common. So
That's
that
correct.
one
Those are
computer-
known as reserved ports,
right,
which
And
means
so there's a
you're not allowed to use them unless you're using it for the purpose, in this case, HTTP, which is insecure or clear text web traffic is port 80 and secured or HTTPS is port 443. Exactly. And there's a bunch of them. Usually they're mostly in the bottom 1024 ports.
Like FTP is another port that's used specifically.
Correct.
SSL, I think, is another one.
SSH is 22.
SSH, rather.
Are these software ports?
Yeah, they're magic things inside. They're
The
like,
software, there is no physical port.
No, do you remember in one of the videos from the last time at the layer 3, okay, which is where IP lives, okay, you have 4 pieces of information. You have a source IP address, which is, the A.B.C.D, a source port, a destination IP address, and a destination port. Okay? So that's just defined, as part of the protocol. And
Yes.
when you want to send traffic from your laptop to Google on port 443, your computer will put its source IP address in, and it will randomly assign an available port for the source port. Okay? So that way, if you have 2 connections to Google happening at the same time, they'll both have a destination IP address of Google and a destination port of 443, for example, and they'll have the source IP address of you, but they will have different source ports. And that's how the computer, and all of your networking infrastructure differentiates which one goes to one window versus another window or another tab.
the easiest way to think about this, if you can recall, way back in the old days when you had post offices and you had people that would sort the mail manually, they would be sitting in front of this huge array of little
Bins.
square boxes.
Yeah,
And so each port is like a bin. So each device in your computer would be like a bin. If there's a letter or a message for port 80, it goes into this box over here. If it's 443, it goes into that box over here. 22 goes into this one. 1746, it goes into that one, which is a private port for something. Whatever it is. And that's the analogy that the computer is using. And then and when you get your mail, you would go to that box and you would take the mail out of that box for you. If that was where the postman would give you that mail when you go there. And that's how the whole thing works. It's the same thing happening electronically in your computer.
And invaders couldn't guess what the ports are? No, they just say uniform.
There are 65,000.
But if certain ones are commonly used,
There are reserve ports, and the communication that you just described is typically from client to server, where the outbound packets in the case of a home network use those well-known
Right.
port numbers, and they're in the reserved range, usually from 0 to 1024. And then the return is a high numbered port. If you're using a NAT system, those are generated on the fly for each connection that's established, for each internet socket connection that's made. A different dynamic port is assigned.
Right, and depending upon the level of security that you have, each packet may in fact be on a different port. It floats around a lot. You can have random ports.
That would be bad. Like whoever was talking over there talked about the notion of a connection. Okay, so when
I misspoke. Seth. Each packet is in fact terribly wrong, but you have multiple connections and each one.
That's correct. That's correct. But for a given connection, in other words, from your browser tab to wherever website you're going to, that connection, so the endpoints, the source port, source IP, destination port, destination IP, will remain the same for the duration of that connection. Okay. Now, back in the old days, it used to be that every time you went to a website and came back, you might establish a new connection. So then it would keep changing. And then, so HTTP had other mechanisms like cookies and things to be able to maintain continuity while the connections are tearing down and reestablishing. So it looked like you have the same session. So I'm using all these terms, but session is kind of like when you log into a website, and you're doing stuff. That's a session. That's an application concept. Whereas a TCP connection is something that's happening under the covers.
Right.
That TCP connection could break, and get reestablished. You could lose connection to your network and then it comes back and it reestablishes a new connection. But because that session ID through a cookie is still there, the website knows how to kind of keep reestablish where you were before so you can keep going.